Welcome to Multi-Mechanica. For my entire life, I've loved building things. It's the challenge of learning new things that keeps me going. The harder and more involved a project is, the bigger the payoff is. Over the past several years, RC has captured my interest, specifically multi-rotors. I decided to finally document my journey on one of my builds. This will be Prototype 1. I hope you follow along and enjoy. So what is this thing? It is a Quadcopter. It's a 250 size micro quad. The most important thing that you need to know about it is I want it to be waterproof. Our family spends quite a bit of time in the summer up at our boat, a little sailboat. I wanted something that I could fly when I was up there, and I've been too scared to take this guy out there, which is my 450 size, just home built H quad. So I wanted something that floated, that was fast, that I could throw FPV on, maybe hang a camera off of. So I've decided to design this little 250 quad. Hopefully will float and hopefully will be waterproof. Where are we at on the project right now? Well, I'll give you a quick overview. I've done the digital designing and come up with a basic shape. That's the front, that's the back, that's where the flight controller goes, motors. This is the lower plate, which I cut out tonight, and started sculpting down. This is the underside, so from this angle. This will be vacuum formed on a vacuum former. Here is our first vacuum formed ABS panel. So I think it came out exceptionally nice for the first pull on this material. Starting to think about the top half. To start the designing for the top half, I simply laid out the components and took detailed measurements to try and figure out how everything would fit. 3D modeling was used just to create the general shape, so that I would have templates to cut out for each layer. After tracing the templates, I then cut them on a bandsaw and a jigsaw. I don't do any finishing work until the thing's all in one piece. I check the whole time for clearances with things like motors to see how far I'm going to have to sand certain components down. After clamping it and letting it cure all the way, then comes the really laborious part, which is the sanding. The 1-inch belt sander and then the 1/2-inch finger sander didn't quite touch it fast enough, so out came the right angle air grinder. Everything has to be finished really smooth to produce a good mold, so I take everything to 400 grit after using filler to fill all the imperfections in the plywood. This is my vacuum forming box. I mount the ABS in a frame, clamp it all down, put it in the oven, and then form it. And then out comes the part. Cutting down is also quite a difficult process. It can be made a lot easier in the future. The use of the things like the Dremel makes it a little better, and then there's just a lot of finishing work to be done. I have a frame. The molding process went pretty well. Happy with how the curves came out. The motor mounts look good. The whole thing is generally probably about 50% where I need it to be. The main problem I have now is when this was all one piece, there was no deflection whatsoever. You know, I could apply a lot of twisting force and nothing would happen. Once I cut the hatch out of it, now there's a fair bit of deflection as I twist it. In normal casual flying, won't be that big of a deal. I've added a bunch of little tabs, locators on here, and I'm going to add some more. That will help tighten it up a bit, as well as when I add the straps to strap this hatch down. That's going to need to be worked on. This one also, I've had to give up on the waterproofing. My casting, or my molding was pretty good, but I sanded a little too tight on some of the corners and punched holes, and that's okay for the first one. I just want to see this one. We're just going to get it flying, and that's the main purpose of this first one. It's to find out what don't I know going into the next one. The good news is the weight is 100 grams. That means we are all up weight with motors, battery, everything should be just under 500 grams. Right now I'm working on soldering together the flight control board. We should be looking at a test flight in a couple of days. At first, flying around calmly, the thing seemed to perform really well, but I started to notice something odd. As the battery ran down below 4 volts, it started to get extremely sluggish. And then this happened. Every time I would go for a flip, one of the rear motors wouldn't restart. I've probably crashed it 100 times in the last 2 days, and it's being held together almost exclusively with tape and chunks of neoprene that I'm super gluing onto it kind of everywhere to hold it together. We'll deal with that durability issue later, but it would appear the frame worked. It did what a frame is supposed to do, but I had a bad motor, or a bad ESC, or possibly the flight controller is bad. I don't think it's radio issues. I've already had what I thought was one bad motor. That might have just been a bad soldering job. The frame portion, which is the portion that I was meant to test, I haven't even really gotten to check other than to crash it a bunch and go, yeah, it will crack if you hit pavement from 50 feet up. So now all that's left to do is I ordered new motors, I ordered new speed controls. I'm going to do what I can. I'll swap. I have one more spare of these 1806s. I'll swap in the one more spare on this ESC, resoldered and all the wires fixed up. Tape the frame back together and try one more time to see if I can get kind of a working package together. So in the end, it wasn't the flight controller or the speed controllers. It was the motors, but not because of anything the motors did, but because of the way I put them together. Those of you who work on quads a lot know that if you put in a screw that's too long and it touches the windings on the motor, it will short the motor out. I've done this before and I've already learned this lesson, but normally if you do this, what you get is a motor that just stutters and won't spin. Due to the fact that these are plastic case motors, however, what it actually did was just short the winding to a different part of the winding and reduce the power and cause the motors to overheat. With a mostly ruined quad and a bunch of destroyed motors, you may be tempted to say that this was a failure, but in reality it was far from it. This was a fantastic learning experience on the way to the next build. If you guys are curious, please subscribe. Thanks again for watching. Bye.